Hi guys, welcome back to the session 7 of object-oriented programming, and here we are going to discuss something about Java exceptions, right? Okay, now let's begin the session of question and answers. Okay, before going into deep inside. Before analyzing, critically thinking about Java exceptions, let's start with a question. Okay, so what if there was no exceptions, right? So what if there is no exceptions, no nothing? Like if everything is so common, right? Then certain things might happen. Is like if the error that happens is not checked. Okay, so if there was no exceptions, error can occur anytime and nobody will know what is the real cause of the error. Okay, so this might create a problem because this is not this might not be so much useful for small programming language, but this is very useful in case of object-oriented programming, where the keyword for the programming criteria is usually for the large programming skills. Okay, where we do programming for the larger scale. So if the local error happens, then while executing a method, then this method causes an unconditional program interruption, right? So the program is interrupted now. Okay, nobody knows what is the cause of the interruption. Okay, so this happens if there was no exceptions. So sometimes this error occurs, the program returns the special value, and these special values are different from null or -1. Okay, so each developer must remember the value and meaning of each special values while checking each error call, so that this kind of situation, okay, of whenever the error occurs and the special value is returned, okay, so this kind of situation creates tediousness in programming, because the programmer has to remember each kind of special values. Okay, so these special values are different from each other. Okay, so the cause of the special value and the special values has to be remembered, and this kind of situation creates tediousness in programming. Okay, so this is the reason, this is what it happens if there will be no exceptions. Okay, so now we do error handling. Okay, so what kind of real problem can occur? Okay, now we do error handling. Okay, let's say there was exception, there was some kind of error handling to handle those kind of errors. So what kind of real problem that can occur then? Code becomes messier and lengthy to write and harder to read. This kind of real problems that can occur if we start doing error handling. Okay, and now you can check out the example here. Like I have given an example here in the reading a file, right? In this example, in reading a file, the procedure is, what we have to do is we have to open a file, then we have to find file size, then you have to allocate the memory, then you have to read file into memory, then close the file. Okay, for case 1, the solution that is given in the case 1 is correct but lengthy. So how? Okay, let's check out the solution. Int read file is a function, is a method. In this method, okay, in this method we open the file. Okay, so we start checking now, we start doing the error handling. If operation fails, then return -9, any kind of number. Okay, find file size. If operation fails, then return -8, and allocate the memory. Now if operation fails, okay, so each time we check, we start doing error handling. Okay, and which return special values. So each time this is done. Okay, for each kind of allocating memory, for closing the file, reading file into the memory, then again closing the file. then at the end closing the file. If operation fails, then return -5, and at the end ultimately return 0. Okay, this closes the file. So this is a correct solution, but it's very lengthy. So each time, for each conditional check, we have to also start handling the error, right? So what about a short solution? Okay, for case 2 there is a very short solution, and it's very wrong. It is short and quick, but it is wrong, because in the read file method you can check out like there is no any kind of cheater. So we do the operation of opening the file, we do the operation of finding the file size, then allocating the memory, then reading file into memory, then closing the file. Ultimately we return the 0, right? This is very short, but it's very a wrong solution. So what can be the best solution? Yeah, this is the best solution. The best solution can be this one. Okay, this error handling is done by like throwing the exceptions and generating the exceptions. Okay, now the solution with the exceptions is shown here, and what is done is inside the method what we do is we just try. First we try all the coding is done here. We try all the method. Okay, so we open the file, finding the file size, allocating the memory, read file, and closing the file. And whatever exceptions or whatever error occurs is catched by this catch keyword. Okay, we catch the particular error by using the catch keyword, and if any kind of error occurs, like while opening a file, if the error occurs while opening the file, then this file open failed error like exception is cached here, and we just throw the respective exception here. And similarly, each whatever exception occurs here is cached by the respective catch method, right? Catch keyword. And this is very handy. Okay, this is very easy, and this is very like something that is more organized and more understandable, right? Okay, this was all about the examples. Now, so how error handling mechanism occurs in Java then? The basic concept is whatever code that causes error will generate the exception. On this basic principle, we are just going to use the mechanism, okay, to handle the errors in the Java. So whatever code that causes error will generate the exception. So handle the error by throwing the exception, and this exception is defined in a new class, that is an exception class, right? So Java mostly has a three kind of keywords. Okay, so first is a throw, and second one is the try, and the third one is the catch, right? So the mechanism is throwing exceptions. Okay, and this kind of exceptions is already defined somewhere in a new class, and whenever you try to use this exception class, then you have to create a new object of this class, and respectively it works. Okay, so this will be discussed later on. Okay, it's just coming just after after a few questions. Okay, so, and the next question is, what is the procedure of generating exceptions then? What is the method? What are the steps, right? Yeah. First we have to declare the exceptions class. Okay. First is always the declaring the exception class. Then the second, we have to have the methods that generate the particular exception class. Then create the exception object. So whenever you want to throw the exception, use throw keyword. Okay. There is a throw keyword that throws the exception object. Okay, yeah. What's the next question? It says that, like, how do we use the throw keyword to generate the exception? the method interface must be declared. Okay, the method interface must be declared. The exception type generated within its implementation if more list with commas. Okay, what do you mean by this? Like something like we also have given a particular example here. Okay. But theoretically if we start saying there is some method, okay, some particular method, and it's something like an interface, okay, so which is already declared, which we have to declare, okay, and which is later on implemented, okay, later on implemented in the sense like you can implement multiple method, okay. If there are more than one method that need to be implemented, then you can implement the more than one method. The basic concept is like the exception class must be there, and the exception class must have some particular method which handles the particular exception of the particular type, okay, and this particular depends on the criteria, okay, whatever criteria the programmer decides to have, okay, this kind of criteria is used, and it is possible to use this kind of exception handling. Yeah, in the case of throw, the execution of the current method is interrupted immediately. So this means, like for example, if any case occurs, like if there was an error and we throw the exceptions, then immediately the current method is interrupted. In two ways we can throw the exceptions. So what are these two ways? Are like either exceptions throw occurs directly by the method that you call, or you generate by some other methods that are defined in the other classes or which are not included in your method, okay, and which can be called within your method. So any other methods which throw the exceptions, then that can be called in your method, right? Okay, the simple example is given here. We created a product class that extends the exceptions, and the string object is initialized with app, okay, and the method, okay, throws error product name exception, and the conditional check is occurred here. So if the object name that we have declared is equal to the particular string apple that I have given here, then throw the exception. We create a new object exception, okay, error product name exception, then we throw the particular exception object. And this is the simplistic way of using the throw keyword to generate exception. Okay, what is interception then? Yeah, in this mechanism of error handling, we just try to run the code, okay, in the first part, and in the second part, all the exceptions generated in the code portion is cached. So first is try your code, try out your code. Then second, catch the error, whatever errors that occurs while you try the code, you just catch the error here in this catch block. Try block and catch block, okay, so you have like two blocks, trying and the catching part. Okay, now next, like how does the execution flow occurs in the exception generation then? Like what is the flow? Like the flow chart I see, like what are the steps, how does it flow, how does it go from try block to the catch block, like how does the situation occurs there? Okay, so if your try block has some kind of methods, like for example you have method 1, method 2, method 3, right? and this kind of methods are working serially. Like, then on the catch block we have some kind of exception. Okay, then you can see this flow in two cases. Okay, if neither of the method generate exception, so neither of the method that generated the exception, then all the method executes. So this means like none of the method has error. Okay, error coding inside them. So all the method are equally, they are okay. So in this situation nothing happens. The method executes smoothly. Okay, all the method executes. But okay, in the second case, if the method 1 generates the exception, okay, and method 2 and 3 are not going to generate the exceptions, then if the method 1 generates the exception, then method 2 and method 3 will not be executed. They will be skipped. Okay, so the idea is like if the first method is already generating the exception, then method 2 and method 3 are all like they have to be skipped because they will not be executed anymore. Okay, and method 1 like automatically it generates the exception and exception is thrown. Okay, now let's take a note. A note is like we can also perform multiple catch by using separate catch block. This means I have already discussed before in the previous question. I already discussed like whichever method, okay, has a error, like while finding the file size you generate some kind of exception, then this exception is catched by the particular like exception like particular exception catch block. So in this catch block, like this particular exception, size determination failed. Okay, so if we fail, there is an error in the file finding the file size, then the particular error is generated, is catched, is caught. So you start catching the size determination failed is caught. And similarly, if anything happens, closing the file, there is an error. So you just catch the particular error, file close failed, right? Okay. Yeah, this was just about this was some small note about like we can also have multiple catch block. What is the exception hierarchy then? Hierarchy means there are some kind of like superclass, subclass, like something like from top to bottom situation, right? So a subclass throwable is subclass to error and exception. So the exception that you are using has also a superclass, and this superclass is throwable. Okay. So this subclass error, what does it contains? It contains some kind of internal errors. Okay. Some hardware failures in virtual machine. Some kind of like out of memory error. Okay. So these errors are unchecked. What about the exceptions then? So in this exception subclass, like we have some kind of programming errors, okay, which contains the runtime exceptions, null pointer exceptions, and these are particularly unchecked. And whereas also we have checked exceptions like class not found exceptions, no such method exceptions, right? Okay, a point to be noted is unchecked exceptions. Okay, what are these? What are those? Okay, these are those kind of exceptions which can be thrown at any time. Okay, the caller do not have to handle them explicitly. This means like a caller, a developer do not need to call do not need to check it. Okay, they can, these are already these are the exceptions, they are already provided by the Java library, right? And these are unchecked exceptions, whereas some checked exceptions are those which you have to check it manually, you have to try it manually and then catch them. Okay, you can check them manually. Declaration is needed and checking them is also needed, like if you want to use a checked exceptions. Okay, now the second note is like we can also use the keyword finally. Finally is like used to specify the actions that must be always executed at the end. Okay, when like by whatever means this must be executed. This means like you can also you can try your code, and also you can say that finally you can also say something, or you can try the code, then you can also catch the exceptions, and also you can finally say that like execute this method, right? Okay, now going on to the next question. How do we handle exceptions in case of loop? For example, your code has some multiple, you are iterating something, okay, something like so how does it like it means how do you check exceptions in case of loop or iteration? Then I can see two cases in this situation, like either if you have a single iteration, we use the try catch block. You have a try, then you try your code out, then you catch the particular exceptions, right? So and you try your code out, and you catch the exceptions, like means in a loop, I said. So the try and catch are present inside the loop. So this means like for each iteration you try a single one, you try a code iteratively, you try a single code, then you catch, okay, if the particular code catch the exception, so then you catch the exception, okay, then you proceed with the next iteration, right? So this is inside the loop. But also in second condition you can see like what if like your loop is inside, okay, what if you want to check the whole loop, okay, like a loop at once, not a single iteration at once, because previously in the first condition we checked a single iteration at once, right? And if this iteration like caught some kind of error, then this error was catched by this catch block, the exception was caught. But when you want to check out the whole loop, okay, as a block, then what you do is you try the whole loop as a block. The loop is inside a try block, then you catch the exception and it is performed all at once, and whatever is scored is inside the loop. So this is the way how you start checking the exception, you start handling the exception in case of the loop. Okay, now going through the preparations for testing the exceptions are there. Just two for developers. I just suggest two kind of preparations that you have to use. Most importantly, is first is accepted exceptions test. Like it means we expect any anomaly, and so we should throw exception. if you expect any kind of error or any kind of some disturbance or any kind of code error, then so you should throw the exception. Okay, accepted exceptions must be thrown. But in this case, in this particular case, you must be careful, like if the test fails. So what can lead to the test failure is like if no exceptions is detected. You expected the exceptions, right? But no exceptions were generated or no exceptions were detected. So in this case, like the test fails, right? So this kind of particular case must be handled. Okay. So you must be very careful in this kind of situation. So in the second case is like you did not expect any kind of exceptions. Okay, unexpected exceptions test is like we expect normal behavior. Okay, we didn't expect any kind of exceptions. So in this case, no exceptions should be raised, right? So but if the exceptions is raised, then the test fails. So just we have to handle these two kind of particular precautions. Must be like the safety aid. Okay, the safety must be used while using the exceptions. Okay, while generating the exception. Now, lastly for this session, the last question we when should we choose between the checked and unchecked exceptions? Then we can use, there is some, I have provided some particular rule for checked exception situation, because previously I discussed about there are some in the class exceptions hierarchy. I discussed about like there is unchecked exceptions and also there are some checked exceptions, right? So like when should you choose among these two? Like when you have to start choosing among them while coding, like when should you choose, like I should use the checked exceptions, and when shall you choose the unchecked exceptions to use? Is like the master rule is like think of unchecked exceptions as a testable condition before the code executes. And what does it mean by this? This means like, for example, like this particular code, object X calls the method do something. This code throws null pointer exception. Okay. So what you have to do is particularly you have to check conditionally. You have to check if X the object is null, then you have to do something here so that the method, the called method is executed and it will not throw the null pointer exception. Okay, so something you have to modify somewhere while modify the X so that the method do not call the null pointer exception. Okay, so then we have to use the we have to do, so this kind of, in this particular case we have to use the checked exception. Rule for checked exception is something like this, like something is checked here. Okay, so it's something like a testable condition, so this can be tested, right, before the code execution, and it is tested in this particular case before it is executed. Okay, this surely it is going to execute through the null pointer, but it is checked here, like, okay, and then something is done here, like it is called again so that it doesn't throw the null pointer exception. So in this particular case we use the checked exceptions. Whereas the master rule for unchecked exceptions is like, think of checked exceptions as a, this is think of unchecked exceptions. Okay, this is unchecked exception as a untestable condition. Yeah, that may occur while the code executes. That may occur while the code executes. This means, like, for example, while you are using this particular method to connect to Google, okay, by using this socket method, okay, the DNS server can come down anytime. Okay, there is no like, you know, there is no sure, like 100% you cannot be sure, like this particular like the DNS server is always okay. So sometimes the DNS server can come down, right? So in this kind of situation, we use unchecked exceptions, because this is the case in which like it is not possible to use a test conditions. Okay, it is something that is not out of the context, right? Okay, now this was all about the Java exceptions. Now lastly, we'll go through the next session and we'll discuss more about the upcoming topic. But this was all about the Java exceptions, and I strongly recommend the developers to use Java exceptions, because in object-oriented programming, Java exceptions are the tools that help us to recognize the error very easily. Alright? Okay, thank you.